In this video, I want to keep talking about complex numbers and specifically numbers involving negative square roots. Okay, so in previous math classes, you may have seen some basic rules for multiplying and dividing square roots of numbers. Okay, you may have seen this familiar rule. So the rule for multiplication, you may have seen the square root of a times the square root of b is equal to the square root of a times b. And the rule for division looked a little something like this. If you have the square root of a divided by the square root of b, this is the same thing as the square root of a divided by the square root of b. Okay, the truth behind this is that this only works when both a and b are positive. Only works for positive a and b. Okay, so if you have one of them negative, you have to simplify it. You have to simplify it by removing the I from the square root before you can do anything with it. Okay, so that's just a way we define things in math. So that's just sort of how it's set up. So that's something you always have to remember. If you have any square root of a negative number, you have to quote pull an I out of it, I guess, before you can do any of these, or before you can use any of these rules. Okay, so knowing this, let's take a look at a couple of examples and see if we can solve them. So the first one we have here is we have the square root of negative 3 times the square root of negative 15. Okay, remember, we have to deal with the fact that these are negative square roots first. Okay, so the square root of negative 3 is equal to I times the square root of 3, and the square root of negative 15 is equal to I times the square root of 15. Okay, now this is equal to, we have two instances of I, so I times I, so that's I squared, times the square root of 3 times the square root of 15. Okay, so this is actually equal to negative 1, because remember I squared is negative 1, times the square root of 45, because we can write this as the square root of 3 times 15. Okay, and we can actually just rewrite this as negative 1 times the square root of 9 times the square root of 5. Or we can actually just think of this as negative 3 times the square root of 5. Okay, so hopefully you've seen how to deal with multiplying and dividing square roots before, so that shouldn't be overly new to you. If it is, I'm sure there's some examples you can look up online for more, or if you want more details on it, feel free to shoot me an email. I'll be happy to make some more videos explaining this. But really all we're doing here is we're just using these basic rules for multiplication, for division, for how to come up with this. Okay. And for this particular step here, we just use that backwards, okay? We know that 45 can be written as 9 times 5. Matter of fact, let's just go ahead and write those steps out so that you can see that here. All right, so we know that this is negative 1 times the square root of 9 times 5, okay? Which is the same thing as negative 1 times the square root of 9 times the square root of 5, or negative 3 times the square root of 5. Okay. Let's take a look at this next example. Here we have the square root of negative 55 divided by the square root of 5. Now again, you may be tempted to use this rule for division here, but these only work for positive a and b. So we have to deal with the square root of negative 55 before we can use any of these rules. So this is the same as I times the square root of 55 divided by the square root of 5. Okay? Or we can really write this as Now because the square root of 50, because 55 is positive and 5 is positive, we can combine them. And we can write this as I times the square root of 55 divided by 5. But 55 divided by 5 is just 11. So now we have I times the square root of 11. And since 11 is a prime number, we can't factor it. So that is as simple as we are going to get it. So we have I times the square root of 11. Okay, next we have the square root of 36, or negative 36, times, or divided by, the square root of negative 2. Okay, so again, because these are both negative numbers, we have to deal with that before we can use any of our rules. So we can write the top as, the numerator, as I times the square root of 36 divided by I times the square root of 2. Now here, what's really nice is that these i's will actually cancel. If I divided by I, this is just like real numbers. If you have anything divided by itself, it'll cancel. So, no, I mean to do that. So we'll have I divided by I, so these will cancel. And we get the square root of 36 divided by the square root of 2. And now we can use our division rule. So we have the square root of 36 divided by 2. And this is equal to the square root of 18. Okay, but the square root of 18 can be written as the square root of 9 times 2, or the square root of 9 times the square root of 2, or 3 times the square root of 2. Okay, so really just using these rules for adding and or for multiplying and dividing square roots just takes practice and learning how you can factor and rewrite numbers. Okay, here we just use the fact that you can write 18 as 9 times 2, and then you can divide, you can separate those two into two separate square roots. So there we go. There's another little, at least a few more tools you can use for dealing with complex numbers.